Good morning, everyone. I'll be presenting our paper titled How Visualizing Emotion Affects Interpersonal Trust and Task Collaboration in a Shared Virtual Space. This research first explores 9 visual representations of amplified emotions in a virtual space, leading to a bidirectional emotion sharing system called Femoji.io. The second study investigated the effect of explicit emotion sharing in interpersonal trust and task collaboration through 3 conditions: verbal only, verbal plus positive visual, and verbal plus honest visual using Femoji.io through the proposal of a framework of 4 factors, which are usability, integrity, behavior, and collaboration. The results indicates the Femoji.io's frequent emotion consensus as a task milestones and positive interdependent behaviors between collaborators, which help develop conversations of firm decision-making and build familiarities and trust between strangers. Moreover, we discuss how our study can inspire future investigation in human AI agent behaviors in large-scale multi-user virtual environments. Understanding one's feeling and reaching emotion consensus build empathy in face-to-face communication with increasing of collaboration in shared virtual space. SVS, such as alt space, VR chat, it is also essential to understand whether visualizing emotion in a virtual environment affects usability, such as users' distribution of attention, the use of verbal and visual modalities to express feelings and reach consensus, and the cognitive load for input and output experience. Face-to-face interactions trust building is supported because people can access in-person communication cues with such as facial expressions, body movements, and gaze directions to provide assistance in making judgments on trusting a person or a person's statement. But these cues are absent when interactions are moved to the remote environment. During a VR remote collaboration, it is uncertain whether one person's emotion reacts to independently with the other when judging if the emotion towards a statement or an object from is genuine. It is also difficult for people to judge the truthfulness of using verbal expressions as a single parameter to and from the collaborator. Therefore, adding explicit visual input to and output from as a second parameter in SVS may differ users' interdependent behaviors because interactions are not as intense as in person can be, and control can subtly change these attributes. We define emotion visual representation as implicit emotion sharing, which refers to cues that usually come out naturally during person's communication, including facial expressions, body orientations, gesturings, gazing, etc. Explicit emotion sharing are those cues that people intend to show with a certain degree of control or emphasis using external assistance. Adding user control in our approach supports a more flexible visual representation for explicit emotion sharing to observe the collaborator's feelings and behaviors. Emotions therefore visualized in simplified scale of feelings, controlled by the user's display and compensate for verbal communication, making consensus easier to notice as a decision-making milestone to improve social trust and task collaboration. An overarching research questions therefore proposed: is sharing explicit emotion controlled by the user necessary to be included in SVS to build trust, improve collaboration? In the following slides, we attempt to answer this research question through 2 user studies and a proposed framework. This workshop collects expert evaluation on interface designs representing emotion sharing in SVS using a hypothetical cooking scenario. The users could represent their emotions responses in 5 levels, L3 being the mid-value, through 3 design themes and 3 view in real time. To support the main study, the goal is to evaluate each design turning abstract emotion information into a simple visual representation that users can input and output in SVS. So the interface consists of a 3x3 grid of 9 conditions. There are 3 themes using data visualization, emoji, self-assessment mannequin, SAM, and ambient environment. Data visualization uses a traditional pie chart to represent an individual's emotional changes in percentage level from 0, 1 to 100% L5 in 5 states, 20% increments. 3 variations of views are based on the amount of visualized information made available to view, leading the aggregated view A, world locked to the middle of the field of view of the shared each user's HMD to understand aggregated mutual emotion. Aggregated plus collaborative view A plus C by locking a collaborator output view from the bottom right of the shared view for quick identification of collaborators' feeling, and aggregated plus collaborators plus users individual view A plus C plus I, where user individual's input is instead world locked to the bottom left of the shared view by moving the collaborator's view target lock onto the avatar, making both view bidirectional available for easy identification. So the result suggested that the most preferred design was to illustrate emotion in emoji SAM for the easy emotion processing understanding. The most preferred view was A plus C plus I because it is not only affirmed that the users of their own input but also allows them to identify emotion easier with a lower cognitive load. So 2 studies, a pilot study and a formal study, were conducted to understand how explicit emotion sharing affects trust and collaboration in SVS using a symmetrical cooking task scenario that we mentioned before, and the associated behavior patterns to the use of modality between collaborators who have no previous interactions. So the study was conducted in a controlled lab environment. The final design choose the emoji SAM in C plus I bidirectional view, reduce the amount of the visual information and brought the focus into the same space without the need to navigate between the controllers, the VR input, the task targets, basically task environment, and the collaborator's emotion, the visual output of the collaborator's emotion. So framework is proposed to evaluate Femoji.io or similar explicit emotion sharing system and applications. The UIBC framework consists of 4 factors: usability, integrity, behavior, and collaboration in 2 measures, metrics and the questionnaire using mixed methods. 36 participant age and an average of 39.6 with a balanced gender distribution were recruited. We deployed between subjects designed of the 3 levels, 1 times 3, baseline, no visual, and then only verbal, and then N, that's called N, and then B, which is verbal plus visual in a benevolent environment, and then H, which is verbal and visual with the honest environment. So those are the 3 conditions. A study facilitator played a collaborator role in controlling all conditions based on a script guideline with a neutral verbal tone. So N, which is the baseline condition, only had verbal modality enabled through the generic avatar in SVS to share implicit emotions, whereas B and H provides a few emoji IO to allow explicit emotion sharing through both verbal and visual input and output. B condition was controlled by the facilitator with only positive input, versus H is with the honest input covering the entire level from level 1 to 5 to understand effect of integrity and behavior. So based on the eye tracking data, we found out that the visual was enabled, participate a significant amount of attention to both their collaborators and their own emotion changes. Most of the participants prefer both verbal and visual modalities, using visual representation to further reinforce mutual understanding when the emoji reaches emotion consensus, help with the decision making, as they provide extra aid for both parties to explicitly reiterate or revisit a change of emotion represent from the past phase to the current phase during collaboration. Controller activities also indicated that participants showed a significant amount of positive feelings expressed to the collaborator in B and H conditions, showing positive correlation between the numbers of positive emotions to the number of total emotions. Comparing it with subjective data, we suspect that positivity could be perceived as a sign of willingness to trust, because trust did not equal honesty. System log suggested in both B and H conditions, emotion consensus between participants and facilitators showed a positive correlation to the number of total emotions. It is possible that using visual representation to express emotion explicitly help the frequent expression of emotion in a deeper engagement in reaching emotion consensus. Interview also suggested that the participant rely on visual emotion consensus as the affirmation of mutual decision while reaching each milestone. Without the emoji, participants suggested decision-making took longer, indicating lacking reference of emotion milestones. It potentially adds more mental effort to reach an agreement. So one of the interesting feedback suggested that although participants hoped for honesty from the partners, they tended to become looser and on larger scale of social interactions. For example, participants expressed that they would expect to see more positive emotion in a multi-user environment, where they felt that they might trust the group more if the more people are showing positivity. Honesty seemed more important to a one-on-one level of intense engagement, where positivity was more suitable for large-scale social SVS. Among almost half of the participants reported their personality as neutral or negative, although our results showed the general positive emotion representation. Some of our participants mentioned that they tended to be more positive towards others due to their personality or cultural influences. One participant with autism suggested that using visual control to express feelings was extremely helpful, as the emotion were hard for them to convey, and offending people verbally in the wrong way would make them anxious. So they felt that emoji could be further iterated or developed to help their group. So users also find it relatively unnatural to use controllers to express emotion, which is one of the limitations, especially when the majority of our participants were novice VR users, being average age of 40. Moving forward, we plan to include more natural input methods such as social gestures, thumb up, thumb down, micro gestures like tap, pinch, and smaller movements, or customized sensors using buttons, clickers, or hand waving to trigger those emotion sharing. Trust itself also has many definitions and constructs, and conceptualizing it through visual representation is also challenging, which is also one of the limitations. The interpretation among different people with different personality, disposition, cultural background, previous history is deemed different. Our study only touches the basic layer of trust in collaboration in certain demographics, and the result can be different based on their user group. So lastly, to summarize, this paper presented a novel method to explicitly share emotions through a bidirectional visual representation called Emoji.io, and propose a framework to evaluate the effect of the system in a shared virtual space. The first study explores emotion sharing from 3 themes and 3 views to 1 simplified visual representation between 10 experts. The second study evaluates the effect of bidirectional explicit emotion sharing in 3 levels: verbal, benevolent, visual, and honest visual, in trust building and task collaboration using a framework from 4 factors: usability, integrity, behavior, and collaboration. Results suggested that adding explicit visual cues yields frequent emotion consensus as task milestones, and interdependent behaviors, which is positivity without causing imbalanced attention, and modality distribution. Combining positive visual emotion explicitly with honest verbal nuances implicitly potentially support trust building between strangers in SVS, because users perceive positive emotion as a sign of willingness to trust, and honesty as a consistency in trust. And inconsistent human-to-human behavior, for example, visual and verbal are inconsistent, can be suspected as AI, exerting further investigation on how behavior can be compared against human AI agent trust building relations. The same applies to how our study design can be used to explore positivity, honesty, and negativity in a large-scale multi-user collaboration. SVS. So in the future, we also plan to integrate the findings from explicit emotion sharing to intervene in implicit emotion sharing, such as testing and validating our UI/BI framework on facial expressions or biofeedback with explicit sharing method through further user studies to provide a more natural system to express emotions visually with control to support trust building and task collaboration. Thank you very much for your time. If you have any questions, please feel free to review our paper and also email me for any questions. Thank you very much.